Bismillahirrahmanirrahim. This question is from October November 24, variant 22. Question number 1, topic measurements and units and measurements. Part number A, state what is meant by vector quantity. So, vector quantity means such quantities having magnitude and direction. So, having quantities that have magnitude and direction. Quantity having magnitude and direction. For example, velocity, acceleration, displacement, etc. B part. A sphere falls vertically through a liquid that has a density 830 kilogram per meter cube. The sphere has a radius r and constant velocity v. Okay, as shown in figure 1.1. The drag acting on the sphere is given by the formula 6 pi eta RV, where eta is the property of the liquid. Determine SI base unit of eta. Okay, to find out the base unit of eta, I will rearrange this equation and make eta as a subject. So eta will be equal to, I will ignore the constant 6 pi, okay. So to make this eta as a subject, it will be written as d divided by r into v. D is the drag force. D is the drag force, right? So you know that force is always in Newton. So Newton is equal to kilogram meter per second square. Another thing that is given in this question, that r is the radius. So radius is always in meter and velocity is in meter per second. So if I put all the unit in this formula, the arranged formula, so drag force is kilogram meter per second square, radius is in meter and velocity is meter per second. If I rearrange all these things, then I will get kilogram as it is. Here is power 1, here is power 1, here is power 1. This and this cancel. So this m is shifted as a numerator, m power minus 1, s power minus 2 already mentioned, and downside minus 1 will be written as plus 1. So final unit of the eta is kilogram meter minus 1 s power minus 1. This is the SI unit for eta. State an equation shows the relationship between the magnitude of the weight, drag force, and upthrust. As it is mentioned by the examiner that this object is a sphere has a constant radius and constant velocity. It means this object have a constant velocity downward as given in the question also. So when object is moving downward, then obviously the weight of the body definitely acts downward. And you know, whenever an object is moved in a fluid, then the drag force always acting opposite to its velocity. So velocity is downward, so then obviously there is a drag force, and I will mention this drag force as Fd, plus the water exert a force that is named as upthrust force. That upthrust force is also upward, so I will write that upthrust, same upthrust. Okay, so the equation shows that weight of the body will be equal to the drag force plus upthrust force. Number three part of this question. The volume of the sphere is 4.6 cubic centimeter. The drag d is given 0.32. Calculate the weight of the sphere. Okay, so upthrust is equal to rho g and v, by this is Archimedes principle. So density is given in the question. I think it is in the previous part. That is 800. 830 kilogram per meter cube. So density 830 kilogram per meter cube. Gravity is 9.8, and volume. The volume is already mentioned, but this volume is in cubic centimeter. Okay, so if I convert this cubic centimeter, then I have to write 4.6 into 10 raised to power minus 2 and power 3. Why? Because this is centimeter, centimeter, centimeter. So 10 power minus 2, 10 power minus 2, 10 power minus 2. So it can be written 10 power minus 2 power 3. So after solving this question, the final upthrust force acting on the body is 0.34. Let me check with the calculator once again. Okay, so calculator gives me the answer 0.37. Uh, 0.037 Newton. I have to find out the weight, and according to the part number 2, the weight is equal to drag plus upthrust. So to find out the weight, W is equal to drag plus upthrust. So drag is 0.037 and upthrust is 0.032. It is given in the question. So if I add this plus 0.32, then the final answer I got, the calculator gives me the answer 0.357, and rounded off answer is 0.36 Newton.